Hi everyone, these are going to be the lecture notes for Module 28. In Module 28, we're going to look at how consumer and investment spending are determined and their impact in our multiplier that we went through in the last module. So a couple areas that we're going to discuss, some kind of points of focus are going to be the aggregate consumption function right here. I do not like white. We'll talk a little bit about how interest or investment is determined, how interest rates come in and determine our investment spending. And then the big thing we'll talk about, and this is perhaps the most confusing, is how unplanned inventory investment plays a role in the fluctuations of our business cycle. So when I take a step back, what we're really trying to do in this chapter is sit down and focus on over time, and we're experiencing this today. We have gross domestic product, and we know gross domestic product is a measure of our country's output. We care about it because as we produce more, it creates more jobs, right? And that's our ultimate goal here. So we focus on GDP largely because of its usefulness as a measure of economic activity, which is really what we care about. So when we look at economic activity, we know over time it kind of fluctuates like that. What we're trying to explain is those fluctuations. Why are they small, right? What can we do to minimize those fluctuations? If it's a deep recession, what can we do to get back to a strong recovery? If we're overgrowing and we're overheating, what signs do we observe? How can we prevent that from happening? So those are the questions we're going to try to answer throughout these next few modules. So as we explain these fluctuations in the business cycle, we build a model. And what we're trying to do is I'm going to put this up here, trying to explain GDP. And we know GDP is determined by consumption, investment, government, and net exports. We're going to take this now a step further and ask, well, what determines consumption? What determines investment? What determines government? And what determines net export? So to start, we're going to make this really simple equation. We're going to say consumption is C equals this equation. And so this equation says consumption equals A plus MPC times YD. A is consumers. C is consumption. YD is disposable income. MPC we learned in the last module is our marginal propensity to consume. And A here is what we call autonomous consumption. I'll talk about that here in a second. Just an aside, for those that kind of are having a hard time with this equation, it is the same equation as something that looks like this. It is an equation of a line. This is going to be a linear line. It's going to be a constant slope. It's going to have a slope of MPC and an intercept of A. It is essentially a line. So what we're looking at here when we look at consumer spending is a graph that shows how consumer spending relates to our income. So what we're trying to think about are all these variables that can explain consumption. And we're going to start with disposable income because it's probably the most important. It is the biggest. It's the strongest determinant of consumption. And what we see is almost this nice, perfect relationship, right? It's almost linear. This is actual data. So these dots here are the level of consumption for income for someone in the 20th percentile of income. This is the 20th. This is the 40th percentile. This is the 60th, 80th, and then this is the top percentile. Right? So they're actual data. And what we observe is this nice, almost perfectly linear relationship between disposable income and consumption. And in real life, this line is about consumption equals about 20,000 plus 0.67 YD. So essentially, this is the slope of the line. The slope here equals our MPC, which in this case, the example I just gave is 0.67. So what that means is as income goes from, say, 40,000 to 50,000 to 60,000, every 10,000 increment in income, consumption is going to go up by about $6,700. And that's really what this is showing us, right? So remember your slope of your equation, right? A slope of a line is rise over run, right? We can typically say the rise is change in y over change in x. Well, that's what we have right here. I don't know why I went to red. Remember that consumption function we had, c and y. Slope, the rise is the change in c, and the run is the change in your disposable income. So the consumption function really is going to be our a linear line. Down here, we're just rewriting this, and this is that example I just said. Suppose your MPC was 0.67. We increase your income by $10,000. Consumption will change by $6,700. So this is just a more detailed graph of that consumption function. Draw it out. We have disposable income. So remember what disposable income is. YD, for our purposes, is income minus what we pay in taxes plus what we get back in transfer payments from the government. It's what we have to spend. We have consumption up here. We have a consumption function. Intercept is going to be A. Slope, change in YD, change in C. We don't want to do those. We want to do those, right? Equals the rise over run, which is MPC, right? And so the equation of this line is A plus MPC times YD. Now, A is an interesting term. So the way we interpret A, if you ever think about what the intercept is, it's the value of consumption when YD equals 0. So you're probably thinking, well, how can you have consumption if your income is 0? And the answer is probably from past savings or you're going into debt. You're just spending more than what you're taking in. And in fact, that's going to be true for a lot of people around here, right? A lot of people with a low income are going to be unable to save or have retired or have built up wealth that's driving their savings. So we've already done this, right? Driving the slope of the consumption function. But just again, to reiterate so we can get practice on doing it, we know slope is equal to rise over run, right? In a normal equation of a line, right? Rise is the change in y over the change in x. In our example, we have consumption equals A plus MPC times disposable income. So our rise over run is change in C over change in disposable income, which we know from the last few slides is the definition of our MPC. So this is just now putting those dots together, right? And so really, where does this equation come from, right? It's a simplified equation for sure, but the idea here is that what we're doing is we're looking at, oops, not Y. We are looking at data to see which variables determine consumption. Because when we look at, again, going back to that business cycle story of trying to minimize fluctuations in the business cycle, we know when we come back to GDP, I'm going to put blank page up. We know when we look at GDP, right, what we have is these spending terms. So we want to understand which variables determine consumption. Consumption makes up 67% of GDP. So if all of a sudden there's a change in GDP, it's likely because of a change in household consumption. So if we know all these variables that affect household consumption, the government policymakers can kind of pull these triggers to help stimulate the economy. So right now, for example, we know GDP, right? We're doing this. We have time, GDP, right? Economy was growing and all of a sudden it kind of fell off a cliff as we've shut down all these non-essential businesses. And we know the big driver here is going to be consumption and investment. Both of these, investment's only about 20%, but both of these are going to take a huge hit. And their impact is going to be felt through a massive reduction in GDP. So for policymakers, we want to understand, okay, which variables, if we lower interest rates, how much is that going to boost consumption or investment? If we lower taxes, how much is that going to boost consumption? How can we sort of pull these levers, hit these triggers to get us back to there as fast as possible? So let's do a practice question. Suppose that when Sue's disposable income is $10,000, she spends $8,000. And when her disposable income is $20,000, she spends $14,000. Sue's autonomous consumer spending is equal to blank, and her MPS is equal to blank. So we basically are trying to find the slope of this consumption function. So how do you answer this question? So first, be careful. We want to find the MPC as our starting point. MPC equals the change in consumption over the change in disposable income. Now, I know a lot of people are going to just go quick, throw in 8,000 over 10,000, you'd be wrong. We're taking the change in consumption. So the change in consumption is 14,000 minus 8,000 for a change in disposable income, which is 20,000 minus 10,000, 6,000 over 10,000. So my MPC is now 0.6. We know that. So my MPS is 0.4. So we can already get rid of a few of those, right? Because remember, MPC plus MPS equals 1. So if this is 0.6, by definition, this has to be 0.4. Okay, so that's that. So this autonomous consumption is the level of consumption when income is 0. How do we find that? Right? So, okay, so to get to this, we're going to go back to our consumption function. I'm going to do this in red. C equals A plus. Now we know our MPC is 0.6 times YD. So really you can get this to this answer by plugging in any 2 points on our line and solving for A. So let's plug in 2 points. We have a point here. There's 1 point. And then this is another point. So let's plug in 10,000 and 8,000. So consumption equals now 8,000 equals A plus 0.6 times 10,000. And so here we have 8,000 plus A equals A plus 6,000, or 8,000 divided by 6,000, A equals 2,000. So we can go over here to D and answer this. Now, you would also be very quick, and this would be fine to do. You know autonomous consumption is not 0. Again, that's sort of a trick where they want you to fall into that trap. It's going to be 2,000 because we know the slope is, by definition, always going to be positive when we look at the consumption function. So that's how you would solve it.